Since I've been, that's the first photograph I've seen of anybody.
And who is that photograph?
It's one of my sons. I can't remember his name.
Tragic. Clive Wearing, this remarkable man, shows us how central memory is to our existence. Without it, life is empty, it is meaningless. How then do we go about studying this magical process of memory? It is convenient to divide the study of memory into two parts: the systems problem of memory and the molecular problem of memory. In the systems problem of memory, we ask where in the brain is memory stored. In the molecular problem of memory, we go from mind to molecule. We add a mechanism whereby this storage occurs. In tomorrow's lecture, we're going to go from mind to molecules and consider the molecular underpinnings of memory storage. Today, we're going to discuss the systems problem of memory. Historically, the systems problem of memory addressed an even larger issue, and that is, can any mental process be localized to the brain? The first person to address this question was a Viennese physician by the name of Franz Joseph Gall, an extremely interesting character who had a lot of insights into the brain. Two of them were so profound that we continue to carry them and entertain them very seriously today. They're fundamental to brain science. The first idea was that all mental functions are biological. They come from the brain. He did away with the idea of dualism that Descartes was advocating, the idea that there are aspects of mind which are outside the body, they're spiritual. He said every mental process, from the simplest reflex to the most extraordinary symphony that Beethoven was composing, these are all products of the mind. He made the second point that the brain is specialized, and particularly the outer part of the brain, the cerebral cortex, the covering of the brain, doesn't function as a single organ. It's a number of different organs, each of them mediating a different mental function. Now, in order to localize mental functions, he had some knowledge of the brain. He knew that the brain was a bilateral symmetrical structure. It had a left hemisphere, it had a right hemisphere. He knew that it was a convoluted structure. It had infoldings called sulci and outpouching called gyri. These infoldings provide a means whereby you can take a large surface area like the cerebral cortex and pack it into a smaller space so you can put it safely within the skull. He also knew that the brain had four lobes: frontal, parietal, temporal, and occipital lobes. And he began to think how to localize mental functions. And when he first began, he realized that four functions are not enough to explain what needs to be explained, an inadequate number of subdivisions. He needed more than four subdivisions because when he read the literature in psychology and from his own clinical experience, he realized there were more than 40 different mental functions that he had to localize. So the question is, how was he to do this? One way to do this is through clinical pathological correlations, to take people like Clive Wearing and see where is the lesion when one has a deficit in memory. But he decided he would do this a different way. He would do this by observing people very carefully. He didn't want to study the diseased brain. And he decided there would be 40 different functions, and he identified them in different regions in the following way. He put the intellectual functions like comparison, thinking, cautiousness at the front of the brain. He put the emotional functions like romantic love, parental love at the back of the brain, and he put sentiments like hope, happiness in the middle of the brain. Now, how did he decide to go about doing this? He thought himself a very careful observer, and it struck him that one clue to how the brain works is to look at the shape of people's skulls. Because he was struck with the fact that people with different shaped skulls had different character structures, different kinds of personalities. And he thought that by looking at the bumps on their skull, he could get a very deep insight in how they functioned as intellectual and social human beings. The first thing that gave him a clue about this was the fact that when he looked at the brightest people he knew, both among his classmates and among his teachers, he found that they had a very prominent forehead, often had bulging eyes. And those that had a more shallow intellect had a more restricted forehead and sometimes a more prominent back of the head. I was extremely skeptical of this view. I thought this was just blatant nonsense. How can one make an assertion like that? But then I began to look around among my friends, and I began to explore them and look at their heads. And I found to my amazement that Tom Jessel, one of my brightest friends, had a very prominent forehead, and some of the people in our group who had a shallow a shallow intellect had a less prominent forehead. So I really began to think that maybe there's something to this. And I began to read more about Gall. How did he get to this view? And he really developed a very, very interesting theory. He thought that if you use your function, like Tom uses his intellect, that part of the brain that represents that function, for example, a function of comparison, intellectual function, that would bulk up like a muscle when you're exercising. And that would cause the overlying skull to bulge out. And this made an enormous impact. People, when they first read about this, got very excited. And I could see there might be some merit to this.